Okay, so tonight I want to share some information with you about mathematics and certainty, which clearly we think that math is a little bit more certain maybe than some of the other areas of knowing. I think you'll find that maybe that's not so. So with math, we've already talked about how there's a formal sense of formal reasoning that happens, that we're using deduction most often. And so we have a couple different kinds of propositions or premises, as we've talked about with propositions and paradigms. And so we have two different sets. The first set is that of analytic versus synthetic propositions. So analytic propositions are true by definition. Very simple. Synthetic propositions, likewise, are any proposition that's not already analytic. But the confusion happens a little bit more with the second set. So if we look at this, we have a proposition is said to be knowable a priori if it can be known to be true independent of experience. So basically, what we have to use here, since it has to be independent of experience, we need to be able to use induction. And we're using this induction because we have to make assumptions based on experience. So with a priori, it's induction. And then a proposition is said to be knowable a posteriori if it cannot be known to be true independent of experience, which basically means that we are using perception. And my writing is awful, but that just basically means we're using perception. So we need to consider, once again, two different sets of propositions: analytic versus synthetic, and a priori versus a posteriori. The second two might be a little confusing, and we're going to do an activity in class tomorrow that should help that make better sense. So what you need to think about in terms of mathematics and certainty is, to what extent do you think a geometric paradigm can be applied to other areas of knowledge? Clearly, we talked about the human face, and we talked a little bit about using mathematics in economics and things like that. But how else do we use math in terms of maybe evaluation or other things that we do in other areas of knowledge? So think about that. And if we use a geometric paradigm, then we need to consider the dangers of that geometric paradigm. And so we have this. We're talking about Euclidean geometry, and that's what we most often cover in public education. However, there's another kind of geometry. And so Friedrich Bernhard Riemann, if I'm saying that correctly, he replaced Euclid's axioms or propositions with contraries, so with opposites. Others believe that the system would lead to a contradiction and so that it would collapse. However, we have found that both sets of propositions and axioms, rather, and theorems can essentially coexist in a different way. Learned this. So here are these axioms. Sorry, I did not intend to do that. So what we need to look at are that 2 points can determine more than one line. All lines are finite in length but endless, and that there are no parallel lines. So there are three basic, and my little tags are missing. There are three basic axioms, and then there are three basic theorems. All perpendiculars to a straight line meet at one point. Two straight lines enclose an area, and the sum of the angles of any triangle is greater than 180 degrees. And so most people would think, what? This isn't possible. This is contrary to everything we know. However, if we look at this, we can see that it is possible. So if we look at a sphere rather than a plane, we can see how this particular set of geometry also works. And if you have questions about this, we'll cover that tomorrow. So, little extra credit. Who here can figure out what this image is? And that's all I have for you today. I hope that you have a great, great evening.